morning, youngsters. We're going to whip out this section. It's section 6 of chapter 9. It's on secants, which is a different word you may not have heard yet. Secants, tangents, and angle measures, okay? So a secant is a line or line segment that intersects a circle in two places. So this would be a secant, okay? Remember that tangents intersect a circle in just one place instead of two here. And there's no way that a line can intersect in more than that. Do you see that? There's no way I could draw a line and have it intersect in, this just can't do that. Okay, so there's three things, there's three relationships that they're going to want you to know. The first one is theorem 9.12. And it basically says that if you have two secants, and let's just call this A, B, C, D, and maybe this is angle 1, okay? So angle 1 is right here. So when you have two secants, let me read it to you. It says if two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So, I know that's a mouthful, but it's pretty easy. This angle measure is 1/2 this plus this. So if this is 20, this is 30, then this angle measure is 25, right? Add those together, you get 50. Half of that is 25. So angle 1 is 25 degrees. Likewise, if I add an angle 2 right here, then the measure of angle 2 is going to be 1/2 this plus this. Okay, that's 912. That's if they meet inside the circle. If they meet on the edge of the circle, so this is 913. It's on bottom of page 688. It says that if you have a tangent and then a secant meet, can I draw this? Yeah, something like this. So this would be a secant, this would be a tangent, and they meet on the point of tangency. They meet right on the edge of the circle. Then look at this angle here. This angle is going to be 1/2 the measure of, I get stumbled over those dang words. If a secant and tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. That's what it is. So if we call this angle 1, then that angle is 1/2 of this distance. If this is angle 2, then that measure is 1/2 this distance. Okay? Whoops, can you see all that? Yeah, I think you can. So that's if they meet on the edge of the circle. Now, what's the third case? I bet you can figure it out. The third case is if they meet on the outside of the circle, of course. Whoops, sorry, that was 913. So now this is 914. So we got, if it's two secants or a secant and a tangent or two tangents, okay? But if they meet outside the circle here, then that angle, should do this in a different color, sorry. This angle right here, that is going to be the difference of this and this. $20, $40, then this angle is going to be 20 degrees. Okay? Now, you could, if this was, if I drew this a little bit differently, and you had a secant and then a tangent, it's going to be the same thing. This angle is going to be this minus this. Okay? And then lastly, I guess I could draw it as two tangents. But I think you get the idea by now. If it was that and that angle is going to be that minus that, or that minus that. Okay, that's all there is to it. Now they sum these up in a handy dandy little just section here at the top of page 691. They sum all those up. So they talked about if a secant and tangent, or two secants, meet on the middle of a circle, on the interior I mean, on the edge of the circle, or on the outside. Okay, I think that is all.